Hey everyone, welcome back to the College Algebra playlist. In the previous video, we took a look at polynomials and adding like terms. In this video, we're moving into the multiplication realm. So multiplying polynomials is what we're going to look at next. And there are two methods for doing that I want to talk about. And the methods are called FOIL and the box method. Okay, so let's start with FOIL. Here I'm asked to multiply the binomials. Remember, when something has two terms, it's called a binomial. Okay, so these are each binomials. And FOIL is a technique that we use to multiply binomials together. Okay, so here's what FOIL is. We're going to add up four different products. Okay, so FOIL stands for firsts, outers, inners, and lasts. Okay, and the firsts are the first two variables in this slot here. Okay, so we're reading it from left to right like it's a sentence in English. The firsts, that's the product AC. So that's what we're going to add up first. Okay, the outers, that's A and D. Okay, so we're going to add the product AD to our result. The inners are right here, right? It's B and C. So we'll add the product BC. And then we have the lasts. Okay, so this is B times D. So you can see we have four different possible combinations of products. So that's what FOIL says to do. It says to add up those four products. Okay? Let's look at this actually expanded out. Okay, so when we use FOIL, we're going to end up with the product, with the addition of four products. Okay, so here in blue, my firsts, that's AC. And then here in red, AD, those are my outers. And then here in green, those are my inners. And here in orange, those are my lasts. So that's all FOIL says to do. It's a way we can expand algebraic expressions and multiply them effectively. So my answer is AC plus AD plus BC plus BD. Let's look at an example where we use FOIL to multiply the binomials, and it's a little bit more complicated here. Okay, so let's do this. Let's start with the firsts, right? The firsts in blue here, 2x and 3x. That product gives me 6x squared. Okay, next, we move to the outers. The product 2x times 4 gives me 8x. And my inners, that's 5 and 3x. So the product is 15x. And then the lasts in orange here. 5 times 4 is 20. So then we notice that the two terms in the middle are like terms. 8x and 15x are like terms. So we know how to add those. And we get 23x in blue here. So my solution is 6x squared plus 23x plus 20. All right, next we're going to talk about something called the box method. All right, I'm multiplying the same exact two binomials, so we're going to use a different method and see if we can come up with the same answer. All right, the box method says to treat each of these things in parentheses, right, to treat this as a length and this as a width of some rectangle. Okay? So 2x plus 5 is the length of this rectangle here, and 3x plus 4 is the width. To find the area of a rectangle, we know that we just multiply length times width. So when we multiply 2x plus 5 times 3x plus 4, we're finding the area of this rectangle. Okay? And the area of the rectangle is actually the sum of the areas of these four mini rectangles. Okay, so this partial length 2x and this partial length 5, right, that's the length of a mini rectangle. Okay, length 2x and width 3x. That would give me the area of the top left mini rectangle, for example. Okay, so we're going to find each area and then add them up to get the area of the rectangle, which is the product that we're looking for. Okay? So my first mini rectangle has length 2x and width 3x. So we multiply those together and we get 6x squared. All right, next, the top right mini rectangle, I have a length 5 and a width 3x. That product is 15x. Okay? For the bottom left mini rectangle, I have length 2x and width 4. So that product is 8x. Lastly, the bottom right rectangle, right, the bottom right mini rectangle is 4 times 5. That's the area there. So now we have the areas of all 4 mini rectangles. Okay, so we're going to add those up. It's the sum of the areas of the 4 mini rectangles. And we get 6x squared plus 15x plus 8x plus 20. All right, this should look familiar. We have some like terms in the middle here, right? 15x and 8x are like terms, so we can add those. And we get 6x squared plus 23x plus 20. And that's our solution. It matches the solution from when we used FOIL. Okay, so the box method is great. If you don't like FOIL, I highly recommend using the box method instead. In fact, I want to give you just some advice in general whenever you're multiplying polynomials. All right, when you multiply binomials, use FOIL. It's quick and easy, and it works. But when you're multiplying polynomials with more than 2 terms, use the box method. Okay, the box method is easier to understand. Okay, so let's actually do that right now. Okay, I'm multiplying a binomial by a trinomial. Okay, so my advice here, since we have 3 terms for this piece here, my advice is to use the box method. Okay, so let's do that right now. Notice that I have a partial length 3x squared, partial length negative x, and partial length 4. Okay, they all add up together to give me the length of the rectangle, right? And down here I have 2x plus 1. That gives me the width of the rectangle. You might be troubled by this negative x here. You might say, hey Luke, I remember you said in a previous video that you can't have a negative side length, right? That doesn't make any sense. And I did say that. But the box here is just a model for organizing multiplication. Okay, so when a term is negative, it doesn't mean that that side length is really negative. It means that that part of the area is being subtracted instead of added. Okay, so this is an abstract rectangle, right? It's not a real rectangle with real side lengths. We just use it to find every possible combination of products here, and then we add them all up at the end. Okay? So let's find the area of each mini rectangle. Top left, we have 3x squared times 2x, right? That's 6x cubed. Okay? And then for this mini rectangle, we have negative x times 2x, which is negative 2x squared. Okay? And then for this top right mini rectangle, we have 4 times 2x, so that's 8x. Bottom left mini rectangle, we have 3x squared times 1, that's 3x squared. This mini rectangle, we have a side length negative x and a width 1, so that product is just negative x. And lastly, we have the product 4 times 1, and that's 4. Okay, so we have all the areas of all the mini rectangles. So we're just going to add those up to get the area of the entire rectangle, which is the product that we're looking for, right? This length times this width. Okay, here are my terms. Let's add these together, and I'm going to get rid of the rectangle because we don't need it anymore. All right, our next step is to add like terms, right? So we see here that 6x cubed stands alone, right? There's no other variable being raised to the 3rd power. Okay, so we'll start there. Next, we see that negative 2x squared and positive 3x squared are like terms. We can add those. Okay, so that's what we'll do. 8x and negative x are like terms, so we can add those up in red here. And 4 just stands by itself, right? There's no other constants floating around here, so we can just tack that on to the end. Cleaning up the stuff in parentheses, right, we have negative 2x squared plus 3x squared. That's 1x squared, right? Remember, algebra is about seeing what's not there, right? There's an invisible 1 as a coefficient in front of this x squared here, all right? 8x minus x, that's just 7x. So we almost have what we want. We just need to get rid of these unnecessary parentheses at this point. So our answer is 6x cubed plus x squared plus 7x plus 4. All right, that does it for this video. Thank you for watching, and like and subscribe.